All right, we are going to do a growth and decay practice problem here. And this problem might look familiar from Algebra 2. It might look familiar from pre-calc when we did exponential growth and decay. But we're going to look at this from the calculus side of it. So upon receiving $10,000 from your Uncle Edgar, you immediately invest it in a savings account that increases in an amount directly proportional to the amount in the account. 2 years later, the amount in the account is 10,405. Write and solve a differential equation that expresses the rate of change of value. When will the value of the account reach $20,000? There is a lot in this question. The first thing that I notice is I'm given an initial condition. This is my initial condition right here. That when t is 0, the amount in my account is 10,000. Followed directly after that, they give me the equation I'm going to use. They give me that it's directly proportional. So followed immediately after that, they're saying that these are directly proportional, meaning that the rate of change between A and T, rate of change being dA over dt, that's our rate of change of the amount, has to be proportional to some proportionality constant times A, times the amount. That comes directly from the directly proportional piece of it. The rate of change is directly proportional to the proportionality constant times the amount. And then it follows up with a second condition. 2 years later, the amount in the account is 10,405. So that's going to be T equals 2, A equals $10,405. And then lastly, it gives me one more thing. It says solve for t, so t equals question mark when A is $20,000. So we have a lot of information to go with here. We have a lot of information. Now, in class, throughout this semester, we learned that this is actually going to turn into this. It's going to turn into A equals C e to the k t. That's what we learned. And we could go ahead and derive that using this. So we are going to use this. I'm going to just do a little side note and derive that for anybody that is curious or has forgotten. I want to get my A's to the same side and I want to get my T's to the same side, and I don't want a dA or a dt in my denominator. So this is going to be equivalent to 1 over A times dA. So I divided by A. And this is going to be k dt. So I multiplied by dt. I no longer have a dA or a dt in my denominator. I'm going to integrate both sides. And the integral of 1 over a with respect to a is going to be ln of a. And the integral of k with respect to t is going to be kt plus c. Now, I want to get a alone. I want to know what is it just to be a. And so I'm going to raise both sides with e. So all of this is in the exponent of e. This cancels out, and so I have a equals e to the kt plus c. But our exponent properties says that this is the same thing as e to the kt times e to the c, and e to the c is just a constant. And so a equals c e to the kt. So that's just the derivation of this equation here. Now that equation should look super familiar to you from pre-calc or from Algebra 2. And so what we did here was we showed on the calculus side of it where this equation came from and why. And really it's looking at the rates of change and the amounts. So now we want to know what is C and we want to know what is K. Well, we have enough information right off the bat to find C. Let's plug in our initial condition. So when you plug in your initial condition, you have A is 10,000, C E times K, or to the power of K times 0. Well, K times 0 is just 0, and E to the 0 power is 1. So we have C times 1. So C equals 10,000. So we figured out what C was, and we can plug that back into our equation. Now we want to figure out what is K. That would be the other thing that we need for our equation, because in our equation we need the initial condition and we need to know what K is. And so to figure that out, let's plug in our T is 2. And so we know when T is 2, the amount is 10,405. We now know that C is 10,000. And then we have E to the K times 2. Well, using algebra to solve this, we'd divide by 10,000, we'd ln both sides, and we'd divide by 2. So we divide by 10,000, right? So when I divide by 10,000, I've got my 10,000 in my denominator, and that's gone from here. It's gone. Oops, can't erase those apparently. And then we would ln both sides. So then we would ln natural log both sides. Well, of course, when we natural log the e, that's gone, right? And then finally, we would divide by 2. And so ultimately, we get K equals this business right here. Well, let's go ahead and plug that into our calculator. I'm trying a little different calculator here to see if I can figure this out. So we want the natural log of 10,405 divided by 10,000. And then we want to divide all of that by 2. And so here is our K, 0.01985 dot 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 dot. So here is our K. K equals 0.019. I have to look at it one more time. I was hoping that it would just stay over here. 1985. Let's say 1985. So now we were able to write and solve the differential equation that expresses the rate of change. Okay, so our equation is A equals 10,000 E to the 0.01985 T. We have one more step in this problem. We have wrote and solved the differential equation. We did a great job there. Now we need to figure out what is T when A is 2,000. So we'll plug 20,000, not 2,000. We'll plug in 20,000 for A. So we have 20,000 equals 10,000 E to the 0.01985 T. I'll divide by 10,000 on both sides and I get 2 equals E to the 0.01985 T. I'm going to ln both sides, so ln of 2 equals 0.01985 T. And then I'm going to divide, so ln of 2 divided by 0.01985 equals T. So let's take that handy dandy calculator again. And so we want to know what is the ln of 2 divided by 0.01985, and we get about 34.9 years. So the time to double the money, because 10,000 to 20,000 is double, the time is 34.9 years. So this is what we did. We read the question. We deciphered exactly what it was asking. We wrote off to the side the important information, the initial condition, that next condition that they gave us, and then what we were solving for. Here is our differential equation, and this is the differential equation that expresses the rate of change of the value. So this is the rate of change of the value is directly proportional. We solved it out and we got this equation here. And then we found our initial condition, we found our k, and then we used those to create an equation where we could then solve for how many years.